Bayes theorem. This is the traditional Bayes theorem formula, and it might scare a lot of you away. However, we are not going to go down the traditional way. We go about by cracking this concept using the old probability formula. Probability of any event is equal to the event that you're looking at divided by all the possible events that can occur. We are going to use this formula to crack the concept of Bayes' theorem. Look at this question carefully. In all Bayes' theorem questions, the outcome would be given to you already. Look at this, found to be black. A ball is drawn and the result is already in front of us. So if there are two bags, bag 1 and bag 2. Bag 1 contains 4 white and 6 black balls, whereas bag 2 contains 4 white and 3 black balls. Given that there are two bags, the probability of choosing bag 1 is half, and the probability of choosing bag 2 is half. Had there been 3 bags, the probability would have been 1 by 3, 1 by 3, 1 by 3. Had there been 4 bags, it would have been 1 by 4, 1 by 4, 1 by 4, 1 by 4. In this case, bag 1 has a probability of 1 by 2 and bag 2 has a probability of 1 by 2 because there are 2 bags. Let's examine NS first. Since a black ball has been drawn, it can either come from bag 1 or it can come from bag 2. So choosing bag 1 is half and choosing a black ball is 6 out of the total 10 balls available. Or the probability of choosing bag 2 is half and that of getting a black ball is 3 upon 7. So this is 6 upon 20 and this is 3 upon 14. Adding the two, 18 upon 35. That's our NS. NS equals 18 upon 35. Now talking about NE. NE is the event that we are looking at. NE is black from bag 1. Chance of picking bag 1 is half because there are 2 bags, and that of getting a black ball from bag 1 is 6 upon 10, which equals 6 upon 20 or 3 upon 10. So NE is equal to 3 upon 10. Getting to the old formula, NE is 3 upon 10. NS is 18 by 35. So NE by NS is equal to 3 by 10 divided by 18 by 35, which also means multiplied by 35 by 18. This gets reduced by 3. This gets reduced by 5. The answer being 7 ones, 7 divided by 6 twos are 12. My final answer. Let's look at another question. Let's look at this question carefully and identify the outcome. Has it been given or not? the ideal way to identify a Bayes theorem question. One of the injured person meets with an accident. One of the insured person, meets with an accident. It's a typo error. So scooter driver, 2000. Okay. Car driver, 4000. And truck driver, 6000. The total is 2 plus 4 plus 6000, which is 12,000. So the probability that the driver is a scooter driver is 2000 by 12,000, which is equal to 1 by 6. Similarly, that he is a car driver is 4,000 by 12,000, which is equal to 1 by 3. And that he is a truck driver, it is 6,000 by 12,000. 6,000 by 12,000, which is equal to half. So using total, we have found out the probability of finding a scooter driver is 1 by 6th, the probability of finding a car driver is 1 by 3, and that finding of a truck driver is 1 by 2. Now let's look at accidents or accident ratios. Pointing out in the question that of a scooter is 0.1, that of a car is 0.3, and that of a truck is 0.15. Those are the probabilities of accidents. If I were to put it down, the probability of the accident of a scooter driver is 0.01, which is also equal to 1 by 100. That of a car driver, the accident of a car driver, the probability is 3 upon 100. And the probability of accident of a truck driver is 15 upon 100. So now we have sorted the probability of finding a scooter driver, a car driver, and truck driver, and the probability of accident of a scooter driver, accident of a car driver, and accident of a truck driver. For probability, we need to figure out two things, NE and NS. We are going to be focusing on NS now, as we always do. That the accident has already happened. The accident has already taken place. It has either got to be a scooter driver, a car driver, or a truck driver. So chances of picking up a scooter driver is 1 by 6. And the scooter driver having an accident is 1 by 100. Or it could be the accident of a car driver picking up a car driver and having an accident. So a scooter driver or a car driver having an accident. So the probability of picking up a car driver is 1 by 3, and that of him having an accident is 3 upon 100. Or it could be a truck driver. Spotting a truck driver is half, and a truck driver having an accident is 15 by 100. So probability of having a truck driver is half, and the truck driver meeting with an accident is 15 upon 100. So as already mentioned, this is the probability of having a scooter driver and he having met with an accident. This one is for the car driver and he having met with an accident. Whereas the last one is for the truck driver, selecting a truck driver and he meeting with an accident. So this equals 1 upon 600 plus 3 upon 300 plus 15 upon 200. Taking the common denominator as 600, the answer is 52 upon 600 for NS. So ns is 52 upon 600. Now that ns has been taken care of, we are left with ne. On reading the question carefully, we find out that you are being asked the probability of spotting a scooter driver, that the person who has met with an accident is a scooter driver, which means that you'll have to find the probability of a scooter driver and then he meeting with an accident. So the probability of finding a scooter driver is 1 by 6. 1 by 6. And the probability of a scooter driver meeting with an accident is 1 by 100. And it's 1 upon 100, which translates to 1 upon 600. So even NE is sorted now. It's 1 upon 600. NE is 1 upon 600. As we know, probability is equal to NE by NS. We know NE being 1 upon 600 and NS being 52 upon 600. Simply putting the value, this equals 1 upon 600, which is your NE, divided by 52 upon 600, which is your NS, which also gets multiplied 100 by 52. I'm sorry, 600 by 52. Now this gets reduced and the probability of the event equals 1 upon 52. The right answer. I hope you like this video. Thanks for watching.